Hello, this is an ASLD tutorial which helps you to improve your simulation parameters in order to get more accurate simulation results. Here you can see a laser resonator which is pumped from both ends, and we would like to see if simulation results are accurate or whether we can get a little bit more accurate simulation results by changing certain parameters. The parameters which you might have to change are related to the finite element analysis and the dynamic mode analysis, and here we might have to change the parameters of which discretize the Gauss modes. To see in more detail what kind of grid ASLD was using, we apply the software paraview, and with this software we can see also the discretization grid lines. ASLD writes all its simulation results in the results directory. Here we have chosen the directory ASLD simulation results. When we open paraview, we only have to click and choose this directory, and now let us see how the pump light is discretized by ASLD. To this end, we have a look to the absorb pump profile. Of course, we have only absorption inside, so we have to make a cut. And now here we can see the absorbed pump power. We would like to see the grid lines, and we go to surface with edges, and now we can see the discretization grids, and we see that ASLD is really using a quite coarse grid to resolve the absorbed pump light. What we would like to have is a more refined grid here in the center, and we might use the same grid or a coarser grid outside. So how can we obtain that? We can obtain that by changing the finite element analysis parameters, and what we can do is we can make a refinement here in the XY direction. See, we currently have 27,000 grid points, so when we do a refine here, ASLD is currently using smaller grid, not in order not to increase the total number of grid points, but we certainly would need more grid points, so we click here additionally and increase. Now we would have about a factor 4 more grid points than in previous calculation. Now let's go to resonator again and let us do a run. After waiting a short time, we get the following simulation results. We can see in particular in comparison to the previous grid we get a little bit worse beam quality. Now let us look to the discretization grid which we have used now. We again open absorb pump power, make apply, make a slice, and go to surface with edges. Now we can see that ASLD has really used a much finer discretization grid in comparison to the previous grid. The previous grid you can see here, and this is a new discretization grid. Next, what we should check is how the discretization grid of the Gauss mode calculation is. That one can be changed here. We have currently used 16 grid points in Z direction, and to see how this grid really looks like, what kind of values are used, we remove the previous grids here in paraview, and we open population inversion for continuous wave simulation. Then we can see here the grid used for discretizing the Gauss modes. What we can see here is that ASLD is using really a relatively coarse grid to discretize to discretize the population inversion in Z direction. This is actually not very surprising, because we have chosen here only 16 grid points in Z direction. We certainly should improve that, maybe to 15, because we have a relatively long crystal, so we should use certainly more grid points in Z direction than in XY direction. So now let us do a run again. That should be done very short. And we see now also a small change in the output power. It's going down a little bit, and beam quality also changes a little bit. Now, important to get an accurate simulation results with the dynamic mode analysis, it is important to use enough modes. How many modes did we currently use? Currently, you can see when you look to the choice of modes that we have only used modes up until order 1 in the transverse direction, so we have used only 4 modes. Though when we totally have a beam quality of 4, it might really be that we need more modes. We can see that also when we look to the radii. This is actually the radius of the total beam, but when we click here, we see the modes of each the radius of each mode, and we need modes such that they really overlap to the pump radius. Though that would be the radius of the low order mode of order 1, that 0, this of order 1, and that's of order 2. Now you can see it's very likely that we additionally need the modes of order 2, and when we increase it again, maybe we should even use the modes of order 3 really to overlap the whole region, the whole pump region. Therefore, we again go to Gauss mode calculation and increase the mode order here to 3, and click on resonator again and calculate, and then we should see after not a very long computational time how the output power looks like. You see it actually really increased, and we see additionally an increase of the beam quality, and that should be really a more accurate simulation result. You can check that by additionally increasing the number of modes and refining the grid, but you will see that not a lot the output power and beam quality would change. Thank you for listening to this tutorial.